Okay, y'all, a few more practice questions, something you might see on a test or whatever, dealing with modeling with 2D objects and scale factors. So just looking at linear shifts in dimension here. Let's get down to some questions. It says, what is the scale factor used in the reduction shown? I hope it's clear enough on your screen for you to see this. But if you notice on the two diagrams here, if you look at A and you look at A down here, notice that it's got A prime on that one. In case you were unaware, you should probably know that from junior high, but in case you were unaware, the one that says A prime, that's the image. So A is the original and A prime is the image. So what we have to do is really, to get a scale factor, we just take a similar dimension from one of them and divide by the similar dimension of the other. Remember, it's image over actual for scale factor. I would warn you not to use one of these guys, because you're going to need to find the length of those dimensions first using Pythagorean theorem or something. Use one that lines up right on the grid lines, right on the squares, and then you're going to be in much better shape. So for instance, this one, we can see ED there is 3 units, and we can see ED here is exactly 6 units. Well, this becomes an easy question already. So if the image has a length of 3 units there, and the original has a length of 6, our scale factor, K, well, that doesn't look much like a K. K is, of course, whatever we have on our image over actual, which we saw before. So 3/6, I believe, is a half. If you want to double check to verify, pick another side. So we can see that this one is 4 units long. Is it 4 or 5 there? 3, 4, oh, it's 5. So we would expect this one to be 10 there if it's been scaled down by a factor of a half. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. You got it. So definitely a scale factor of 1/2. We double checked it. Alrighty, next. What's the measure of side x in the scale diagram below? Well, there's a couple of different ways we can do this. The first way I want to show you is with scale factors, and then I want to remind you of your similar triangle stuff that you saw in junior high, and then a little bit more in grade 10, maybe when you were studying trig, we hope anyway. Okay, so with scale factors, I compared two similar sides like these, and I can get that my scale factor here would be equal to, so let's say that it doesn't really matter which one is which. Let's call, x is in the scale diagram, so then this one is the original or the actual here. Actual, and then this one is the image. Pardon my 7-year-old handwriting. So actual and image. So K is going to be 3 divided by 8. Okay, it's image over actual. Then, once I have my scale factor, if I want to figure out what x is, okay, right there, I know that I can use image over actual for my scale factor formula that we have, or we can remember that the image is going to be equal to what we had, K multiplied by the actual. So in this case, x should be equal to our scale factor K, which was 3/8, multiplied by the actual, which was 10. Okay, so that's just going to be 30 divided by 8, and we have a measurement of 3.75. Okay, so x would be 3.75 centimeters. There is another way to do it, which is really more in line, I think, with the theme of proportional reasoning. So if we use ratio and proportion, it should just look just like you did in junior high when you had similar triangles. So if I take the ratio of 3 centimeters to 8 centimeters, and then I take the corresponding ratio, x to 10 centimeters, and then I just solve this equation. So I cross multiply and I get 30 equals 8x, and then x is equal to 30 over 8. So two different approaches are going to give us the same thing. So we get 3.75 centimeters. Okay, so those are some typical questions you might see with this. But remember, scale factors compare the scale diagram to the original using the formula that we had. We multiply by the scale factor to get the size of the image. We divide by the scale factor to get the size of the original. And we can use a scale factor to calculate, or sorry, we can use the factor formula to calculate the scale factor. And it's important to work in consistent units always when we're using this stuff. Okay, hopefully all that is helpful. See you next time.